Okay, so today we are going to solve radical equations. We're going to spend at least 2 days on this. We'll look at some more complicated ones tomorrow when I'm back. And maybe we'll see how things go. Maybe we'll have a little scavenger hunt by Thursday on these. So get your notebook out. If it's not already out, you're going to take a few of your own notes today. I've got 5 examples I'm going to do in the video here today. All 5 of them involve the same 4 steps. Okay, so some of you I know, having steps when you're working through a problem. So when you are solving radical equations, and I've got these steps rewritten on every single page, so you don't have to rewrite them every time. But step number 1 is to isolate the radical. So you want to get your radical symbol on a side by itself. It doesn't matter if it's the left side or the right side, you just need to get it on a side by itself. So step number 1, isolate the radical. Step number 2 is to undo the radical. So if it's a square root, you can square both sides. If it's a cube root, you want to cube both sides. If it's a fourth root, you can take both sides to the 4th power, etc. So again, step number 2 is to undo the radical. Step number 3 is to then solve for your variable. So if it's x, get x on a side by itself. Use your Algebra 1 skills to do that. And then step number 4 is to check your solution. So whether or not it's an official check step that you write it out or you just mentally check it, make sure your answer makes sense in the problem. Make sure it works out. Okay, if it doesn't, it's what we call an extraneous solution, and we'll talk about that a little bit more tomorrow. So again, step number 1 is to isolate the radical. Step number 2 is to undo the radical. Step 3 is to solve for your variable, and step 4 is to check your solution. So the first example we're going to look at is over here on the left. We have the square root of x equals 7. Okay, so we're going to walk through this problem one step at a time. So step number 1, we want to isolate the radical. So notice in the problem, the radical is already on a side by itself. So that's taken care of. Radical isolated. So step number 2, we're going to undo the radical. So in this case, it's a square root. So I'm going to square both sides to undo it. Okay, so step number 2 is taken care of. We undid the radical. So when we did that, when you square the square root of x, you're just left with x. And 7 squared is 49. Okay, now step number 3 is to solve for the variable, which actually turned out to solve once we undid it. So we got x to be 49. Now we need to check to make sure that this answer does make sense, that it does work. So whether you actually formally write out a check step or whether you just do it in your head, it's up to you. So again, wherever you have an x, I'm going to plug in a 49. So we're going to have the square root of 49. Again, does that equal 7? Well, the square root of 49 is 7, so that does work. So 49 is my solution. Okay, I'm going to pause for a minute so everybody's finished writing. Okay, and the examples that I have progressively are going to get a little bit more challenging, not too difficult, but a little bit more as we continue on. Okay, so number 2. Again, you don't have to write these same steps out every time. I've just got them written down on each slide here for something to refer back to. So my problem I'm going to look at on this slide is the square root of k minus 10 is equal to 6. So again, it's a radical equation. It has radicals involved. So going through the process, step number 1 is we're going to isolate the radical. Well, notice the square root of k minus 10, everything in the radical is already on a side by itself, so that's taken care of. So step number 2, we're going to undo the radical. So again, since it's a square root, to undo it, we're going to square both sides. So again, when we square a square root, it undoes itself. So we're left with k minus 10 equals 6 squared is 36. So again, we took care of step number 2, we undid the radical. Step number 3, we need to solve for the variable. So we need to get k on a side by itself. So thinking back to your Algebra 1 skills, to solve for k, we're going to add 10 to both sides. So we're going to have k equals 36 plus 10 is 46. So we solve for the variable. The only thing left we have to do is to check to make sure our answer makes sense. So again, when we check it, wherever we have our variable in the original equation, we're going to substitute in what we got for the solution. So we're going to have the square root, k is 46. So the square root of 46 minus 10, again, does that equal 6. So 46 minus 10 is 36, and you guys should know that the square root of 36 is 6. So this one checks out. Now again, I'm going to keep repeating myself. You don't have to formally write out your check step. Okay, but it does make it simpler. You can see what I'm talking about as we're going along here. Okay, so next up, problem number 3. This time we have a cube root in the problem. So we have 5 plus the cube root of 4n equals 7. So again, as you're jotting that down, going through our steps again, you don't have to rewrite them, but they are over here on the right side. So again, we have 5 plus the cube root of 4n equals 7. So step number 1, we are going to isolate the radical. So again, notice this cube root is not on a side by itself. We have this 5 out in front. So since it's 5 plus the cube root of 4n equals 7, to get rid of the 5, we are going to subtract 5 from each side. So we have the cube root of 4n equals 7 minus 5 is 2. So again, we isolated the radical. The radical is now on a side by itself. So step number 2, we need to undo the radical. Now the previous 2 examples we were doing square roots. So we squared both sides. So if this particular problem is with cube roots, to undo the radical, we are going to cube both sides. So when we do that, it undoes itself. So on the left side, we have 4n. And on the right side, 2 cubed is 8. So again, we just completed step number 2. We undid the radical. Okay, step number 3, we need to solve for the variable. So we need to solve for n. So if we have 4n equals 8, to solve for n, we're going to divide both sides by 4. So we're going to get n equals 2. So the last thing we need to do then is to check. So again, whether you mentally plug it back in or you write out your check step, again, wherever we have an n, we're going to substitute, in this case, a 2. So we have 5 plus the cube root of 4 times 2. Does that equal 7? So 4 times 2 is 8. The cube root of 8 is 2. And 5 plus 2 does equal 7. So this one does check. Okay, so again, my end answer is 2. Okay, so we got 2 left here. Number 4. So we have negative 3 times the square root of 4 minus 3k equal to negative 15. Okay, so again, you don't have to rewrite them, but the steps are on this page already. Step number 1, isolate the radical. Okay, so again, this is the square root part, the square root of 4 minus 3k. So again, I want to get that on a side by itself. Well, what's out in front? A negative 3, and it means negative 3 times that. So again, to get rid of the negative 3, the inverse of multiplication is division. So we are going to divide both sides by negative 3. So we're left on the left with the square root of 4 minus 3k equals positive 5. 15 divided by negative 3 is 5. So we took care of step number 1. We isolated the radical. Okay, so step number 2, we're going to undo the radical. Since again, this is a square root problem, to undo it, we're going to square both sides. Okay, so when we square a square root, again, it undoes itself. So on the left side, we have 4 minus 3k equals, on the right side, 5 squared is 25. So again, we completed step 2, we undid the radical. So step 3, we just have to solve for the variable. So we need to get k on a side by itself. So if you think back to your Algebra 1 rules, the next thing I'm going to do is just subtract 4 from each side. So we're going to have negative 3k equals 21. 25 minus 4 is 21. So then again, to finish solving for k, we're going to divide both sides by -3. So k is going to be a +7. So again, we solve for the variable. The only thing left to do is to check the solution to make sure it does work out okay. So again, whether you mentally check it or you actually write your check step out, that's up to you. So again, we're going to plug in 7 for k. So we have -3 times the square root of 4 minus 3 times 7. Again, does that equal -15? We're hoping that it does. So 3 times 7 is 21. Oh, it should be, I apologize here. Earlier we in the problem. 21 divided by -3 is not +7, it's -7. Good catch. Hopefully you got that as well. So again, if we actually plug in a -7, -3 times -7 is a +21, and 4 plus 21 is 25. Okay, so as we continue to check here, the square root of 25 is 5, and -3 times 5 is -15. So this one does check. So as you can see that I did, I almost forgot about my negative sign, so be very careful. Otherwise your check step is going to hopefully show you that you did something incorrectly. Okay, so we've got one more problem we're going to take a look at here today. Hopefully everything is going smoothly so far. And that is this problem here. So we have the square root of 11 minus n is equal to the square root of 3n minus 25. So while you're doing that, again, I've got my steps over here on the right. Now, when I said earlier you want to isolate the radical, this is one where technically you're going to have a radical on both sides, and that's okay. So again, we've got the radical on both sides. That's isolated. You only want one on each side, if that. So step number 2, we're going to undo the radical. So since we're dealing with square roots, we're going to square both sides. So when you square root, it undoes itself. So we're going to be left with 11 minus n equals 3n minus 25. So we just undid the radical. So we've got steps 1 and 2 covered. Step 3, we're going to solve for the variable. So think back to your Algebra 1 skills. We're going to get an n on the side by itself. So my first thought would be to add n to both sides. So we're going to have 11 equals 4n minus 25. So again, to continue solving for n, we're going to add 25 to both sides. So 4n is going to equal 36. And again, to finish solving for n, we're going to divide by 4. So I got n to equal 9. So we solve for the variable. The last thing we need to double check is to make sure that does check. So again, whether you formally check or you just do it in your head, that's up to you. But again, to check it, we're going to have, or again, wherever I have an n, I'm going to replace it with a 9. So we're going to have 11 minus 9. Does that equal 3 times 9 minus 25? So 11 minus 9 is 2. So we have the square root of 2 on the left. On the right, 3 times 9 is 27, and 27 minus 25 is 2 as well. So the square root of 2 equals the square root of 2. That's equal to each other. So this does check. So my answer is x equals 9. Okay, so for today, you have a worksheet. Okay, there are 22 problems. And on the very last sides, I provided the answers. So make sure you work on these for the rest of the hour. Stay on task. Tomorrow, I'll take any questions that you have. And we're going to take a look at some more problems. We're going to kick it up a notch. Tomorrow's problems are going to require you to factor. Okay, have a great day.